So as I told you, refractive index is a constant, okay, and it is defined as the ratio of sine of angle of incidence to the sine of angle of refraction. And both this ratio this constant is the ratio of this angle, sine of angle. Therefore, it does not have any unit. It is unitless. And one more, this has a physical significance that I would tell you later. Okay, and just now you just understood what is refractive index. This refractive index is the property of the medium that you study later now. Each medium, like air, has a particular value of refractive index. Glass also has the particular value of refractive index, and it has a physical significance. Okay, refractive index of glass is something. Okay, and that something has a meaning. But before that, let me tell you what is the effect of refraction on speed, frequency, and wavelength. As you studied earlier only, as you got to know about the speed, that during refraction, what happens? The speed of light changes. That's simple. Secondly, frequency. See, this is very important. Frequency of light depends on the source of the light, so it doesn't change on refraction. Frequency of light only depends upon the source of light. If you change the source, the frequency will change. But as long as you're using the same source, the frequency of light will never change, whether it goes to one medium, whether it goes to 100 mediums. Okay, it doesn't matter. The frequency of light will remain changed. So frequency of light is also called to be the inbuilt property of light. Okay, it is the inbuilt property of light. You cannot change. It's just like your face. Whether you are in Siliguri, Banahart, anywhere, your face doesn't change. Similarly, frequency of light will never change. What about the wavelength? Speed of light in a medium is given by this formula. V is the speed of light equals to f into lambda. F is the frequency, lambda is the wavelength. This wavelength is the wavelength of light. So from here we can find the wavelength equals to V by f. So f will not change, but V will change. Therefore the lambda will also change. So when the light passes from rarer medium to the denser medium, the wavelength decreases. Why? Because the speed of light decreases as it moves from denser to the rarer to the denser medium. Here we can see that lambda and the speed of light has the direct relation. If the speed of light increases, wavelength will also increases. The speed of light decreases, wavelength will also decreases. Good. Okay. Now speed of light in different media. A relation between the refractive index and the speed of light. Okay, speed of light in different media which we have studied before only. Now, what is the relation between the refractive index and the speed of light? That we'll study now. See, refractive index of a media. There's another one. There's one more definition of the refractive index. This is the mathematical definition which we study now. There's one physical definition of refractive index, but both are same, whether you take mathematical definition or physical definition, because one is the consequence of the other. So refractive index of a medium is defined as the ratio of the speed of light in vacuum to the speed of light in that to the speed of light in that medium. So refractive index mu is the ratio of speed of light in vacuum or air to the speed of light in that medium. So this is one physical definition which is more comprehensible. So it's a ratio of speed of light in vacuum to the speed of light in medium. Suppose you know the speed of, let's take this example of speed of light in air. If you take the speed of light in air, it is 3 into 10 to the power 8 meter per second. The speed of light in that medium, suppose we take the another medium is glass. So light is striking from air to the glass. So air is the first medium. Let's say glass is the second medium. Light is striking from air to the glass, and we want to know the refractive index of glass with respect to air. We want to know the speed of light. We want to know the refractive index of this glass with respect to air. Then the formula would look like this. Refractive index of glass is speed of light in the first medium to the speed of light in the second medium. Okay, so 3 into 10 to the power 8 divided by this, which is 1.5. Now what do you mean by this 1.5? That means the speed of light in air is 1.5 times the speed of light in glass. That's what it means. Now this is the speed of light in air, this is speed of light in the glass. If it is coming 1.5, then speed of light in air is 1.5 times the speed of light in glass. That's what it means. So speed of light measures how how slower the speed of light in that medium compared to the air, or how faster the speed of light in air compared to that another medium. As we know, the speed of light in air is the maximum. So here we can see the speed of light in air is 1.5 times the speed of light in glass. So it is 1.5 times. That's what it gives. Therefore, the refractive index has a physical meaning. Let me take another example. The speed of light in water is this. So first medium is air, second medium is water. The light is striking from air to the water, and we want to find the refractive index of this water. So again we calculate it with the help of speed. Then we are getting 1.33. That means the speed of light in air is 1.33 times the speed of light in water. That's what it means. Okay, you understood the physical significance now. So there's a table given over here: vacuum, air, ice, water, different refractive index they have given. So from here you can understand that this refractive index 1.36 means that 1.36 of spirit means that the speed of light in air is 1.36 times the speed of light in spirit. Okay, that's what it means. Uh, in general, if you go, the general formula of speed of light is the speed of light in medium 1 to the speed of light in medium 2. Refractive index, the general formula of refractive index of the second medium with respect to the first medium is that speed of light in medium 1 to the speed of light in medium 2. All the time the speed of light in the first, all the time the medium 1 is not air. Okay, it can be glass to water also. Therefore, this is the general formula Remember here, we are finding the refractive index of the second medium with respect to the first medium. So always the formula should be speed of light in the first medium to the speed of light in the second medium. Okay, so this general formula we can do it mathematically. V1 is the speed of light in the first medium, V2 is the speed of light in the second medium, and we this we can do C by V2, C by V1. Okay, this we can do. We have just what do we just use C over here, but this both C cancels, so it's there's no effect of this using this over after this. Okay, so we know that V2 is in the denominator and V1 is the numerator, so it is still the same. We have just used only C so that we can modify this formula. C by V2 is mu2, C by V1 is mu1, because we know already over here is that mu is C by V. Therefore we want to write this refractive index in terms of refractive index. So refractive index of second medium to the first medium is refractive index. C by V2 is what? Refractive index of the second medium, and C by V1 is what? Refractive index of the first medium. So in terms of refractive index, if you see, refractive index of the second medium to the first medium is that refractive index of the second medium divided by refractive index of the first medium. But in case of speed of light, we see it is opposite. Refractive index of the second medium with respect to the first medium is that speed of light in medium 1 to the speed of light in medium 2. This is opposite, but here this is same. mu2 by mu1, here it is v1 by v2. Okay, v1 by v2, mu2 by mu1. So they have opposite relation, so do not be confused over there. Using that relation, we can easily find the method. You can easily solve this. Now, what are the formulas you have to remember? You have to know this relation, this very important relation for numericals. One, this, or this one, this two. You can this both you have to remember. One is v1 by v2, and this mu2 by mu1. And one more relation that you have to remember is this one, this two. It's the same thing. So they have arcs and numericals using these formulas. So you can easily solve the numericals in terms of if they give the refractive index of water, refractive index of the first medium, second medium, you can find the refractive index also. If they give the velocity also, you can find the refractive index. Okay. So here they have chosen this. First medium is glass, second is water. The light is traveling from glass to water. What is the refractive index of water with respect to glass? Similarly, speed of light in glass, the speed of light in water. You can easily find it, the refractive index, which is 0.89. That means the speed of light in glass is 1.89 times than the speed of light in water, which is less. Since it is below 1, therefore 0.89 is less. Okay, therefore speed of light in glass is 0.89 times the speed of light in water. But one thing you have to notice over here that if the speed of light in medium is same, then the speed of light will be same if the I'm sorry if the refractive index of both the medium is same. Okay, if you have two medium, both have the same refractive index, then the speed of light in both the medium will be same. And if that is the case, so what will happen? The ray will not change its path when it passes from one medium to another medium, even though the angle of incidence is not zero. What are the conditions for the light to pass undeviated? That we'll do later.